Hello students, today we have a very nice problem of irodov. This is problem number 1.27. It is related to motion in plane. Let us read the problem and try to solve that. This problem will make you understand how to deal with complex problems of the motion in a plane. So let us read this problem and try to understand the concepts lying behind it. A particle moves in xy plane, in a plane xy, with a constant acceleration w. That acceleration w is directed along negative y-axis. The equation of motion of particle has formed y is equal to ax minus bx square, where a and b are positive constants. The question is, find the velocity of particle at origin of the coordinates. So here we have to determine the velocity of the particle at origin of the coordinate. So how to deal with such questions? So first of all, just note down all the given data. Here you are available with acceleration in y direction, acceleration in negative y direction. So I can write here minus w j cap. And if acceleration in next direction is not given, so it can be assumed to be 0. It can be assumed to be 0. So it is x is equal to 0 I cap. One equation is provided here, that y is equal to ax minus bx square. So let us write down that equation. Y is equal to ax minus bx square. Now how to deal with such questions? Whenever you have to determine the velocity and you are available with this equation only. So one thing we can say very clearly, that here acceleration is given. Just by differentiating this y coordinate 2 times, it means second order differentiation, I can compare that acceleration with it, and in this manner this problem will be easier to solve. So let us understand that in a very easier manner. Just differentiating this with respect to time, dy by dt is equal to a dx upon dt minus b, here b 2bx into dx upon dt. You know x square will be differentiated to be 2x, and that I have written in a arranged manner. So you can see here. Now you are well known that this dy upon dt is nothing but velocity in y direction, and dx upon dt is velocity in x direction. Because you know rate of change of x coordinate with respect to time will give the velocity in x direction, and the rate of change of y coordinate with respect to time will give the velocity in y direction. So here from this very first equation, we can see that this particular body which is moving in plane possesses both components of the velocity, that x component and y component. So now what we should do, we should just differentiate it again, because we have to reach to this acceleration so that we can compare that. So we will have something like that, d square y upon dt square, d square y upon dt square is equal to a d square x upon dt square minus 2bx. Now you can see I have to do the multiple rule, that quotient rule we have to use. So that is 2b in the bracket x d square x upon dt square plus plus one time this will be differentiated, and we will have dx upon dt whole square, dx upon dt whole square. Now here you can see that acceleration in x direction is 0, acceleration in x direction is 0, and acceleration in y direction is minus w. Just by having the basic understanding that double differentiation of the x coordinate gives the acceleration in x direction, we can clearly say that there is no acceleration in x direction, so this term will be 0, and definitely this term will also be 0, and now just put the values. We have minus w is equal to minus 2b into dx upon dt whole square. You know dx upon dt is the velocity in x direction, so I can write this as velocity in x direction square. So from here we can very easily determine the velocity component in x direction, and definitely you will get the value of velocity component in x direction is equal to under the root of w divided by 2b, w divided by 2b. Now if you want to determine the velocity in x direction, so there you can use velocity in y direction, there you will use this equation. And one condition is given in the question, that at origin, and you know at origin this particular coordinate x is equal to 0 will make this whole term to be 0, so just by having the basic analysis, we have velocity in y direction is equal to a into dx upon dt, and we have just determined the value of dx upon dt is equal to under root w upon 2b, so that I will use, and we will have a times under root w upon 2b. So now you know that we have the two velocity components. One is component in x direction that you are observing here, velocity component in x direction, and here you are observing the velocity component in y direction. But in this particular question it has been asked you have to determine the net velocity at origin. So we have to sum up all this, and you know velocity in x direction and velocity in y direction, if we are having the net velocity, the magnitude of net velocity is equal to under the root of velocity in x direction square plus velocity in y direction square. Just we will substitute these values, so we will have under the root of w by 2b, that is under the root of w by 2b whole square plus a w by 2b root, that you are getting a whole square. And just after solving and rearranging the terms, we will have something like that if I take w by 2b to be common, so that we will have 1 plus a square. So this is the magnitude of velocity. That is what exactly required to be done in this particular question. So from this question we can understand very easily that whenever you get such complex problems, you have to just determine the velocity components and then sum up, and you will be able to solve such complex questions. So thank you.